Right, we're here at the top of page 3 as we move through the assignment. Of course, it shouldn't be a shock to you that once we get going on a topic, they're going to practice that same thing using fractions and decimals with an emphasis on fractions. So you've heard me say it before, if you're still struggling with fractions, please get the extra help you need. Come see me if you aren't sure where else to turn. We'll get you some extra help, get you some tutoring in that, okay? The one good thing about fractions, you can treat this and just solve it with fractions, find common denominators, work with fractions the whole way through. Or, noticing that there's an equal sign. Because it's an equation, because it's equal, because it's balanced, we can multiply both sides by the same thing, which means that we could multiply both sides, which means every term, by the LCD, and we will eliminate all the fractions. Okay, so when there's an equal sign, you can actually eliminate the fractions, and the way you do it is you multiply every single term, everything in the entire equation by the LCD. And in this case, with 12, 6, 2, and 4, the least common denominator in this case is going to be 12. So I'm going to go ahead and rewrite this entire equation, but multiplying every term by 12. So it's going to be 12 times the y over 12 plus 12 times the 1 over 6 equal to 12 times the y over 2 plus 12 times the negative 1/4. And I'm going to just write all that in. So I've got y over 12, 1/6, y over 2, and negative 1/4. Notice I kept the negative with the fraction, so I'm thinking of it in terms of plus a negative 1/4. You could also have put the minus out in front here and left it as a positive 1/4 on the inside. Notice that I'm writing the 12s kind of up high, so if you need to, you can visualize them as 12 over 1 to do the multiplication. Okay, because the 12 over 12, those are going to cancel each other, leaving just 1 in each of those spots, and you're going to get 1 times y is y over 1 times 1, which is 1, so you're just left with y, or 1y. Whatever helps you the best to make sure you understand what's sitting there. It's a single y or just 1y. Next you have 12 over 1 times 1 over 6. The 6 goes into 6 once, it goes into 12 twice, so you've got 2 times 1 on the top, over 1 times 1 on the bottom, which gives you a plus 2, or 2 over 1, which is 2. The equals comes down. I get 2 goes into 2 once, goes into 12 6 times y on the top, over 1 times 1 on the bottom. That's going to give you 6y over 1, or just 6y. Remember, the point here by multiplying by the LCD is to eliminate all the fractions, so it shouldn't be a shock that all these denominators are canceling out here. 4 goes into 4 once, goes into 12 3 times. 3 times a negative 1 is going to be negative 3 over 1 times 1, which is 1. So negative 3 over 1, which is just a negative 3, or you could write that as plus a negative 3 or minus 3, whichever way makes most sense to you so you don't make mistakes. Okay, and what we did now by taking the time to multiply by a least common denominator all the way through is we've created a equation that looks very familiar to us. We know how to solve this. Now we can go through our checklist. Are there any parentheses that we need to take care of? There's none on either side. Are there any like terms that need to be combined on either side? In this case, no. But we do have to pick a side. Y needs to be either on the left side or the right side. I'm going to go ahead and I guess this time I think I'll move it to the I'll move it to the left side and maybe deal with my fear of fractions here. So I'm going to see what's in front of that 6y. It's not written, so we assume it's a positive. We do the opposite, which will be a minus. So we might subtract 6y from both sides. 1y minus 6y will give you a negative 5y on the left side. Still have our plus 2 equals, still have our minus 3 or negative 3, however you want to phrase that. And now you're in that ax plus b equals c form. You've done all three things. You've gotten rid of the fractions. That was our first kind of bonus step to help make it easier. We checked for parentheses, we checked for like terms, we picked a side. Now we're ready to find out what's happening to y, and let's undo that. So what's happening to y here is it's getting multiplied by negative 5, and then 2 is getting added. So y is being multiplied by negative 5, that again. That wasn't very clear. Multiply by -5, and then the next step is that we would add 2. If you were doing this in timeline form, it would look like this: y times -5 plus 2. Be going from left to right. And then to undo that, we would go up that list, or right to left on the timeline, and do everything opposite. -2, and then divide by -5. Or in this case, step 1 would be a subtract 2. Step 2 would be a divide by -5. Same steps. Both of these processes will get you the same steps. I'm just showing you two different ways to think about it. You find the way that makes most sense to you. Some of you can just look at that and know that the 2 needs to be gotten rid of first. Some of you were maybe taught to look at what's furthest away from the y. Let's get that out of there first. So we're going to start by subtracting 2 from both sides. That leaves us with -5y is equal to -3 minus 2, which is a -5. You can think of that as -3 plus a -2. Same signs. Keep the sign, -5. And then according to our list, as we continue right to left or up the list, we're going to divide both sides by -5. -5 by negative is going to be a positive y, 1y. -5 divided by -5 is going to be a positive 1. So we're getting an answer of 1 here. We need to check that back in the original. So I've got 1 over 12 plus 1/6 equals 1 over 2 minus 1/4. I want to know if I put 1 in there, is that equal? So now you might have to bring in your fractions here. So I've got 1/12, 1/6 is going to be 2/12, 1/2 is going to be 6/12, minus 1/4 is going to be a minus 3/12. And I get 1 plus 2 is 3/12, and 6 minus 3 is 3/12 on the right side as well. So this does check. It's a true statement. So I'm ready to put my answer in set notation. Sorry, I ran out of space again. I needed one more line. My answer of 1. So you do have to do a little bit of fraction work in the checking. But again, it shouldn't be that bad once you've gotten rid of the variables here. Okay, when you're just plugging in to check. All right, let's try number 46 together. Let's do that same technique. If there's an equal sign, and there is, you can multiply both sides, specifically every single term. Everything was a fraction in this first example. Not everything's a fraction, but everything gets multiplied by the LCD. And the LCD, again, in this case, is going to be 12. 12 is the smallest number that both 3 and 4 will go into evenly. You can see why we want a least common denominator, or least common multiple, because we want these denominators to cancel out into that number, to go in evenly. That's how you get rid of the fractions, because they go in evenly to that LCD. Okay, so everything gets multiplied here. So I've got 12 times our x minus 2 over 3 plus 12 times our minus 4 equal to 12 times our x plus 1 over 4. And let's write in what we see here. X minus 2 over 3 minus 4, x plus 1 over 4. And you can make that minus 4 a minus 4 over 1 if that helps you. You can make all the 12s 12 over 1s if that helps you visualize and follow through with the canceling, the multiplying of the fractions here. 3 goes into 3 once, goes into 12 4 times. I'm left with 4 times that entire piece of x minus 2. Okay, the whole thing just over 1, so the fraction's eliminated. Over here, I've got 12 times a negative 4, which is going to be a negative 48, or a plus a negative 48, or just minus 48. 4 goes into 4 once, 4 goes into 12 3 times. I've got 3 times this entire top here, 3 times the quantity x plus 1. So I've eliminated the fractions. I've still created an equation that we still have some work to do before we can start undoing what's happening to x, because now there's parentheses. And this time the parentheses just don't go away when the fractions do. We need to go ahead and distribute. So it's going to be 4 times x, and 4 times a minus 2, 3 times x, and 3 times a 1. So I get 4x. 4 times a negative 2 is going to be minus 8. And then you still have the minus 48. 3 times x is going to be 3x, plus 3 times 1, which is 3. I'm starting to show just a little bit less on the notes, but feel free to ask how. Okay, we've done these step after step after step. so many times. I'm thinking a lot of you have got some of this down, but I'm happy to do anything that you guys need to see more of. Make a note and go, whoa, how'd she get from the blue to pink there? Make a little note, bring it to class, okay? Or ask your help resource if you can't wait that long for class. All right. Then we've taken care of parentheses using distribution. Now we look for like terms. On the right side, 3x and 3 are not like terms. They do not have exactly matching variables with exactly matching exponents. But on the left, we have a -8 and a -48. So those combine. It's as if you're saying -8 plus a -48. So it becomes a -56. So you have 4x plus a -56, or if you want to think of that as just 4x minus 56 equals 3x plus 3. And now we need to pick a side, and some of you may be able to do some of these all in one line. You might be able to do more than one thing in each step, and that's fine too. I'm going to go ahead and move the variable to the left side here, and I get a -3x. You can pick which side. Okay, the reason I do minus is not because of the +3 here, it's because we don't see the sign in front of the 3x. We assume it's a positive, and then we do the opposite of that, which is minus. So I'm left with 1x, or just plain x, minus 56 is equal to +3. I ask what's happening to x, and what's happening is that you're subtracting 56, so we undo that with the opposite. We add 56 to both sides, and we get x is equal to 59. Then we want to check that. Back in the original equation, I've got x minus 2 over 3, the whole thing minus 4, equals x plus 1 over 4. And when I plug in 59 here and here, are those two going to be equal to each other? That's what I'm testing. So 59 minus 2 is going to be 57 over 3 minus 4. And 59 plus 1 is 60 over 4. So what I've got here is 57 divided by 3 is 19, minus 4, which is 15, and then 60 over 4 is 15. So this is a true statement. It checks out, so I can go ahead and set up my answer in set notation. I think I'm off the screen just a little bit, so I'm going to go up high. And my answer is 59 in the little braces to indicate set notation. Alright, we'll see you at the bottom. Well, actually, all that's left here are some try problems, so I think I'll just extend this video a little bit. Slide down here to the 2 try problems. Make sure they're in focus. Okay, and take a moment to copy what you see, talk to somebody, describe it, note any questions, bring those to class, and then try these problems on your own. They involve fractions, so you get to try multiplying all the way through by the least common denominator if you choose to eliminate fractions. If you want to see these worked out as fractions all the way through, I'm happy to do that. Bring that question to class, and I'll do that for you. Okay, hit pause, because here comes the answers to 36 and 44. Hopefully you tried one or the other, maybe even you tackled both of them. Number 36, if you tried it, you should end up with 5/3 as your answer, or if you wrote that as 1 2/3, that's fine. On the right side, you should end up with, or I'm sorry, on number 44, you should end up with 3 as your answer. Okay, we will see you on page 4.